This year, the Nobel Prize in Physics went to the US scientists Rainer Weiss, Barry Marish and Kip Thorne for their involvement in creating a system called the LIGO-detector. This new technology recently enabled scientists to record and prove the existence of gravitational waves. But what exactly are gravitational waves? In 1915, Albert Einstein speculated about the existence of gravitational waves, an idea conceived from his general theory of relativity, because his calculations prove them indirectly. He believed that gravitation arises from mass curving space and time, and not like so far considered without any time warp between the two masses. This curvature would not take place infinitely fast, but rather at the speed of light. Furthermore, Einstein believed that gravitational waves emerge from especially energetic occurrences in the universe. For example, two very large masses that attract and orbit each other, like two black holes or intense starbursts. They release energy radiates into space and deform space-time, and thus forming a gravitational wave. According to the European Space Agency, the ESA, do gravitational waves generated, for example, by two orbiting black holes not even exceed the size of an atom. And because all experimental attempts to observe these waves over the last century were not sensitive enough, the final proof never came. So, how did scientists today manage to do it? On September 14, 2015, waves were detected by the Laser Interferometer Gravitational Wave Observatory, the LIGO, in Washington and Louisiana, facilities separated by 3,002 kilometers. The construction of these identical systems consists of a central building with two linear arms that extend for 4 kilometers on the ground. Between the two arms, laser beams radiate after the principle of the Michelson interferometer, which build interference patterns through the specific reflection of the mirrors. These happen through the mutual cancellation of waves. If no gravitational waves hit them, the arms shall be stretched or compressed differently and led to the changing in the detected interference pattern. If two laser waves overlap with certain properties, constructive or destructive interference can occur. In constructive interference, two wave crests hit each other, so that the amplitude of the resulting wave doubles. In the case of destructive interference, both waves cancel each other out exactly, because a wave crests and a trough with the same amplitude have collided. This can then be recognized as a shadow in the interference pattern. By changing the interference pattern when gravitational waves hit the LIGO, they can be detected. Some scientists celebrate this advance as the biggest discovery of the century. What does this all mean for the future of astrophysics? The answers may be found in the following article.